So as Sydney said, this mill turn webinar series is divided in two parts. So I hope to see you also next week. Today we will talk about some new developments in 2015 version, and I want to show you how to start what we are doing, defining a part, defining the setup, creating an operation, selecting a tool, width holder, all the process in a mill turn. I select a machine which I was unable to create a simulation and a proper post-processor in 2011. I had a customer in 2011, and again in 2015 I have a new customer again with this machine. It's a Wilhelmine 408 mill turn with spindle and a smart device here. It's a part catcher who is able to take the part, is moving with one linear axis and one rotary axis. He's taking the part from the spindle, and we can continue to work on this device. So a few years ago I was unable to create a post and a machine simulation, but with 2015 developments we can do this. So that's the reason that I select this machine. And in previous webinars I come with ready parts and show you this is what I did, this is what I just show you things. Today I want to change this and to do all this with you online. So I have a SolidWorks part. This is the part, and I will start to define online with you all the process and to show you how SolidCAM 2015 is working. So let's start to creating a new mill turn, and we're working external, metric. First thing that we are doing always is creating a coordinate system. And to do this, I create this cylinder covering the part. It's easier for me to create a home, and I will show you why. We always need to use the advanced power of CAD together with SolidCAM power. So create a coordinate system. It's center of revolution phase. I will select this cylinder. I have the part, the home created, and let me show you why I select this cylinder. First, I'm able also in the next process, when I select, when I define the setup, I will be able to measure some things. But the main important issue here on a mill turn that we can work milling on face and on side radial. So for radial, when we select the home, we get those levels, part upper level, clearance level, from the surface that we pick. So that's the reason that I pick the surface of this cylinder covering the maximum diameter of this part. I get directly the correct levels on radial. And I will create now a new home on the back side of the part, Mach 2 position 1, to use on the part catcher. Again, I will select the cylinder, change to opposite, change selected. Pick face, sorry. And change the opposite. Okay, so on the other face of the part, we have Mach 2 position 1, which will be used on operations on part catcher. Let me change a little bit my settings here for the part. I want to show all this to see and not to see the coordinate system. That's the way you want to work. And the next step is to create the stock and target. I do all this manually and not automatic in automatic mode, but you all know that SolidCAM, in SolidCAM settings, you can define this all this process to be automatic in Milton, create the machine setup, coordinate system, fixture, definition of stock and target. I'm sure that you all know this because it's not something new. We just improve some options here. Now, creation of stock, definition of stock. I will define the stock as a cylinder around this part. It's a part from the medical industry, from implants, dental implants. It originally is very small. I just scaled this part a little bit just to work easier on the part. Let's add some material on Z+, Z- and on the external diameter, and generate an envelope. Target definition, the same. I will select the same model, the same body, and envelope to be generated. We are ready to go. We have the target, we have the stock. Next step is to define a setup. But before the setup, because in the setup I will define fixtures and the jaws for the part catcher. Let's first assign the Mach 2 position 1 to part catcher. That's what we do. For turning spindle, we work on Mach 1. On part catcher, you work with Mach 2. And here we need some dimensions, some values in X, Y, Z to position the part in machine workspace. But first, I want to add a fixture because, let me show you again, we have this part catcher. It's a vise, but we don't have the jaws. So the jaws will be added as fixture from the SolidCAM. They are not always the same, and that's the reason we didn't add them as an STL here in machine simulation. Here we have only the vise without the jaws. So using again the power of a CAD, I am going to assembly and insert the component. I'm going to my library, Wilhelmine jaws. I have the jaws here. We rotate them a little bit. Yes, those are the jaws. Which the jaws I save them for all the parts. And sometimes I add some cuts. So if I'm suppressing the last features, the last cut, you see, those are the jaws that I'm always use and mount on the part catcher, but depend on the part, I do several cuts. And suppress, and also the hole here, and suppress. Now, okay, we have the jaws here, but I need to position them according to the part. So I will use mates. Okay, this plane, mate, with the plane top of jaws. Okay, and origin of the jaws, the center of width, will be concentric with the part. And now I need to position them in z-axis. Let's see, I want to catch the part from here. Okay, so the jaws are connected and fixed in the model. Save. Now we can continue with the setup. First, working on the turning spindle with Mach 1 position 1, which is here in the right side of the part. I need to position the part, as I said, into the machine workspace, and I say Mach 1 position 1 is on a distance from the main spindle, from the chuck. So let's measure what is this distance. Is from here, from the face of the part, Mach 1 position 1 to the back side of the stock. So, wow, why I am on inch. Excuse me, my defaults here, document properties, units, I'm on millimeters working. Okay. Give me 3 digits and 3 digits. That's all. So let's measure again from this face to the back of the stock, 30.854 millimeters. That's mean Mach 1 position 1 is on almost 31 millimeters from the chuck. And press on this eye, I see a red dot here. This point is showing me where is the face center of the chuck. So my position is okay. Now I need to also to position this part related to the other device. If I'm starting work directly on the part catcher, the part will be mounted according to the setup. If I'm not starting directly from the part catcher, this setup will be ignored, and I will demonstrate you, and we will take values from the machine control operation, because we have two options. One is to start directly or to manual mount the part on this device. Second, to use machine control operation and create the transfer process. So Mach 2 position 1 on part catcher is where? Is on 11.325 millimeters from the face of the chuck fixture. That's very simple to measure with our tools. So we see the red dot point. Here I define in VMID, in machine definition, the device coordinate system, so it's easy for me to measure from this face up to the Mach 2 position 1 coordinate system assigned to part catcher. So setup is defined, and I need to define the fixture now. For working on turning spindle, I will not define any fixture because we have a collet inside machine simulation. And this is the second body. Our fixture is ready, and I just check. Yes. Great. Now I can hide this because I want to start working. Also, this cylinder, it was only helping me to create a hole, maybe into measure setup, but now I can hide, save, and we can start creating operations. Adding, I will start to remove the material with turning operation. And working on turning spindle, I don't have any option to select another submachine here, because the second submachine working on part catcher is milling only. We don't have any option to rotate the part. And create the geometry. I will start here and using Auto tool, constant Z, select the last edge. This envelope is created by a series of small lines. SolidCAM will go line by line, entity by entity, up to the end. This is my geometry. Approve and modify. Auto extend to stock. So here we can see the geometry is already extended to the stock. And for the end, I will extend it to here, end of the part, and I will add 1 millimeter. It's enough for me. Tool, selection of the tool, add the turning tool, external. Let's move this here and make this window a little bit bigger. Now we have a default tool, but on my machine this default tool with 25 shank width and height is too big. It's a small machine with for small parts, and I need to change it. But first, because of the geometry, we have negative movements in X. This kind of insert is not good for me, so I will select another insert, 35 degrees, and go here and select a 16 millimeter width and height shank. 20, we have the dimension of M, and length should be 80 millimeters. Insert also is too big. Let's make it smaller, and the width is going to be 3.2 millimeter, radius 0.2. That's my tool. Now you see that tool is mounted on a position, on a specific position from the station, because we mount this tool on the turret. On the turret we have the station spindle nose. From this point we define where the tool is positioned in mounting window. Now here we have the previous values of delta Z and X. For the default tool, I need to change them to 80. This is the new length, and 20 millimeters in X is the new M dimension. I don't remember these values, but you can always find them here. This is M and L. Distance from the tooltip to the opposite corner of the tool, because this corner of the tool will be mounted on the STL holder. Okay, so tool is mounted in the correct position related to the station. I'm going to holder, and I have, for this machine, I create a small library. I will select the left one, 45 degrees, and What I need to do is only to rotate the holder around Z, position the tool 45 degrees. Sorry. That's all. I have the tool mounted, defined. That's how I want to work. Pretty easy, no? Position of tool, how we work here on this tool, on this part. I want to start from this side. We can see the tool here. We can see the tool also in the tool picture. We have many previews, which can help us to see the tool correctly. Also, we have tool near mouse. If you really want to see the tool, tool near mouse is also an option. Automatically, because of the holder mounting, tool mounting on in the holder, we get calculated here a B angle of 45 degrees of the spindle. But I'm always allowed to add an additional angle. If I don't want to work with the tool perpendicular to turning axis, I can always use additional angle, let's say -10 degrees. Levels, technology, I don't change here anything. Default options are pretty good for a demonstration. Rough, and let's add finish also. Link, I don't change anything, save and calculate, and we have a job. We have the toolpath. Let's simulate. In turning first is the best simulation for turning. And solid verify. Not a single. Okay, this is my part after turning. Let's see machine simulation. I don't know what happened to me today. It's because of the heat. So, this is the machine. I will hide the machine and make the stock transparent. But you can see here on part catcher, you already have the fixture mounted, the jaws, which I define in the setup. They are in correct place, ready to work. Move list. Let's see on simulations. Upon operation change, I want to stop and go. In turning operation, working and showing you some new developments here in the strategy. We have before only non-descending motions in X direction. Here now we add also non-descending motion in Z direction on the wall. That's a new development for 2015. What should I do next? For a demonstration, I still have material here, so it's the good time to create a drill, remove material, and after that I will define a milling operation to remove material around. So let's create a faster turning drill tool. What tool do I need here? It's 5.5 millimeter diameter. Select, add a drill, We say 5.5, and it's enough to be 40 millimeter outside the holder. Let's go and select also an STL from the global list in library of Wilhelmine. I have a shrink 6 millimeters. This will be good. And the levels, technology from 0 and drill end should be here. Full diameter. And link, I like to work only in Z, 10, also only in Z, go to 10 millimeter. Save, simulate, turning. Tool will be positioned here in 10 millimeters in Z direction. Go to safety and start drilling. And go back to a position I define in a retract point. Okay, so I define a turning, drilling one. Let's define a milling operation. I think the best way for showing you on this surface is to use the swerve 5-axis. You already see how the powerful is our 5-axis module in the previous webinars presented by Ahmad. And let's see how we use these powerful options of 5-axis simultaneous in mill turn, the same as in milling. Add a milling, swerve machining, geometry, automatic. I will select the surfaces around this feature. This and this and this. And I have here also a surface. Okay, it's not selected. It's something with my, okay, and this, okay. And the tool, what tool should I use? I need to measure the radius here on the base of this feature, so I will use SolidWorks curvature. And I see it's 1.72414. Okay, so it can be at 3.45 millimeters a ball nose. Select. Let's unselect curvature. Oh. And a ball nose mill. I say 3.45, 40 millimeters out, and holder, again an STL. I love to work with STL holders, simple to define, just import the model. And here we have almost 4 millimeters. Yeah, let's take it. Levels, I will work with the defaults and toolpath parameters, change it to outside. Link, lead in, lead out. Use lead in and use lead out. Save and calculate. Let's check. I have a toolpath. Yes. Simulate solid. Go around at the part. Remove all the material. Of course, this is not a demonstration of my technological skills. So, of course, I need to do here a rough operation. And we have several options. to do steps by a number of slices. Let's maybe 3. It's there enough. Save and calculate. You can see here on Morph 3 steps. Another option is to use layers. It's the offset option, so save and calculate, creating an offset toolpath around the surface. Have several options. So save and calculate. For demonstration, I'm not really cutting this part on the machine now. Okay, let's simulate all this process and going to the next stage using MCO and moving the part to the other device, to part catcher. But let's see what we did until now. So we have a turning. Increase the speed a little bit. I will hide the toolpath. We have a drilling and the 5-axis simultaneous toolpath, which is moving. Beautiful. Okay. This is my part, and let's start to add a machine control operation. Now I want to control the device to take the part. So my first action will be to send the turret to a safety position because it's still near the part. A new option here in MCO, very easy to use, is not before that you drag or right click here and add an action. Now with a double click you have the device inserted in the list of actions. So milling spindle, movement, right click and go to home reference. A part catcher, double click and start move. Start moving, go to the limit in new axis, which is 80, go up in a vertical position, 90 degrees. Now go to the part and catch the part. But where I should go, I don't know this dimension, but I can measure this dimension very easy. Show, what's happened with my memory? Performance, memory 15. What? Somebody steal my memory here. SolidWorks, Vision, SolidCAM. I don't know why. Maybe I need a restart. Let's close this machine simulation. So maybe my computer will get stuck from any reason, or maybe I have 16 gigabytes, but some process maybe takes more than he need to take, and I will be back in 2 minutes if my computer will get stuck.
Okay, Florian, go ahead.
No, I'm continuing, but if something has happened, I'll be back in 2 minutes.
Okay, no problem.
Movement now to this position, movement of the device to this position and to catch the part. So I'm working from Mach 1 position 1, and I need to bring this fixture here. So Mach 1 position 1, I can easily measure from this face, measure from here up to here. So it's 17.529. This is the position which I need to reach. In part mode, it's easier to work from the coordinate system. Part mode, -17, 529. Okay, so I reach the position. Here I can use jack, close, open, all this stuff. Okay, it's for the G-code. We need now for the simulation. Next step is to use the part move. I move the device only until now, movement. Now I move the device with the part. So using part move, go back to the limit, and you move the device to 0, back to horizontal position, and you again go to 0. Save and calculate. Hide and hide. Save, and let's simulate to see this transfer process, which we can control and define very easy and very precise. We have a total control of this machine. I will jump directly to the machine control. Okay, so the first movement was turret go to a safety position, and now device go in U-axis to have the enough place to rotate the device in vertical position, yes? And go to vertical position, go and catch the part, and it's going exactly in the position as I said. Take the part with you, go down, and go back to position. And now we can continue to work here in this position. I will add here an operation, a milling operation, profile, working on part catcher, Mach 2 position 1. Let's create a geometry. Here, and auto constant Z, tool, let's create a tool, a new tool, an end mill, 8 millimeter, and also I like to add an STL holder from the global list. Wilhelmine library. I will shrink for 8 also. Select levels. Automatically my profile depth is taken from the geometry selection because that's what I have in the settings, but you can change it. And I wanted my tool to reach this depth. Technology, only one finish. Let's increase the radius for 45 degrees and simulate. Let's see in Solid Verify we have any collision. Also in Solid Verify you can see the fixture and to check collisions. So yes, I have a collision. Let's increase the lead in, lead out, only the lead in. Arc 60 degrees, save. And I will simulate all the process in machine simulation. Okay, position this to a better view. Transparent stock, go. Turning, drilling, and 5-axis swerve. MCO, turret to a safety position, device, take the part, and we are ready to work. Also here on this device I can define positions. On Mach 2 position 1 I can continue to define position 2, position 3 on angles, and use the B-axis on this part. Okay, we are limited by the machine, by the B-axis limits and by the X, Y, and Z axis range, but it's definitely possible to work here on position on different B angles. And we have the profile, go around the part, removing material. Of course, we can continue here and to define operation, to clear all this material, to drill, removing the material here on the chamfer. Technological, we have many work to do, but only for a demonstration, just to see the principle, how we work on this machine, I think is enough. But now I promise you to show the difference between using MCO and using the setup. So here in MCO, I catch the part exactly in the same position that I define in the setup. But what's happened if I change the position here? Movement. Let's say that I'm not going to exact this position -17, I'm going to -10. Save, simulate. Machine simulation. SolidCAM will ignore the setup, what I define in the setup. Using MCO, part move, will ignore what we define in the setup and use the new values, because I have the right to change my mind. Okay, take it from here, -10 I am now, not on -17 millimeter. I'm catching the part in a different position. It's my right. And continue to work. Okay, but if I'm suppressing all these operations, I don't have any operation on main spindle, suppress them. I don't have any MCO to take the part and mount on the part catcher. I'm working directly on the part catcher. Information from setup is important, because this tells us where to mount, where to position the part in the machine space. Okay, hide. Let's see, zoom in. The part is positioned correct with setup information. So that's the way we work. We define two possibilities from the start. First of all, I have the setup and tell me where this part will be on the main spindle, on the part catcher, the same on all machines with two tables. But in the middle of program, if I change my mind and want to catch the part from another position, I'm allowed, and SolidCAM will calculate all this. The simulation and the G-code will be generated accordingly to the new part position. Okay, I think this is all for today. In the next webinar, next week, I want to show you on a twin spindle, twin turret machine, a part working on a part synchronized on both spindles. That means a part which I cut on the main spindle, transfer it to the back spindle, and on the main spindle I will bring a new part, and working synchronized. I want to define this process with you and to show how we use the synchronization. And so this is the issue for the next week. I hope to see you again. We have any questions?
Florian, thank you very much. I see there are no questions at this point. Of course, the webinar has been recorded, so you'll be able to review it. Thank you again very much for this well-informed webinar that you did today, and we'll see you again next week in our next webinar. Thank you again, everyone, for joining us, and see you again next week. Take care and have a great weekend.